Welcome to our today's webinar. Today we have the topic this new controller JUMO meroTRON, which should substitute later this DTRON controller. In this webinar, I want to give you a little information. So what is different if you work with this device, or what is special? On the other hand, I want to give you an idea how to make a startup with this controller. So and here I want to give you an overview what you can expect here in this webinar. At first, I have a few words about the hardware, that you know what is possible, what can you connect on this device. Then we have this topic configuration program. This is very important because you will see for the startup of the device, you need to work with a configuration program. It's not possible to make the startup completely via the buttons of the device. The configuration program is free of charge, and I want to show you how to work with this configuration program. So, and then I make a little example with you. I show you how to configure a one-channel controller as a two-state controller. Then I want to show you the operation for this two-state controller, and then we want to make an extension. We want to make a configuration of a second control channel, and then I will show you if you need parameters which you need to configure via the display, via the front, then you need to create a user interface. I will show you. And in this chapter, I want to show you as well how to extend the hardware of the meroTRON. Then I want to show you how to work with this two-channel controller. And then at last, I want to give you an idea of the data logger. So here I show you the meroTRON 108 in the landscape format, in the installation format 4896 millimeters. There is no probe connected on this meroTRON, so the meroTRON has no valid process value, and so in this case it's very normal that the controller is in manual mode. I show you the backside of the controller. The meroTRON has plug-able push-in clamps, and I have connected here the power supply. We have versions with 230 volts and 24 volt. On the backside, we see 6 elements, which the meroTRON offers all the time without the option boards, but I show you this later in detail. So here we have the element 1. The element 1 is for connecting the power supply. The elements 2 and 3 are relay outputs, so with normally open contact. On the element 4, we connect later the sensor. The sensor can be RT temperature probe, a thermocouple, or 4 to 20 milliamp signal. Then on this element 4, we have 2 digital inputs. They expect potential-free contacts. This is digital input number 1 and 2. As an alternative to digital input number 1, you can work with a digital output with voltage levels of 0 volt and 14 volt, and this is then digital output number 3. For the configuration, you need a USB cable. On one side of the USB cable, you need then the micro connector, and here you see, this is a micro plug in which you can give the connector then. This is here the element 6. Element 6 is a USB host interface. Via this interface, you can give the data of the data logger to a USB flash drive. The controller offers option slots, and after buying the controller, you can extend the hardware of the controller with option cards. I will show you later in the configuration program which options are possible. On the device you see here, there is an information how to make the wiring of the controller. Here you see how to connect a thermocouple or RTD temperature probes. On the other hand, you see how to give the outputs of the controller to your actuators. So and now I want to show you where you can get the configuration program. Here I'm on our homepage. And now I can switch here to English language. And then I search for meroTRON. So here in the results, I see here the meroTRON. Then I go to the product page. And on the product page to the download area. And in the download area, now we see here there's a possibility to look here for software free version. And here's a configuration program. You can download here and then you make the installation. So now I will make a little example configuration for you. And for this, you need to know when you install the configuration program, you install automatically the Quick Start Assistant. And then if you connect the meroTRON via the USB cable, then the Quick Start Assistant starts automatically the configuration program. The software opens always the file which was used at last. Now I close this here and I make a new file. So now this file needs to be adapted to the existing hardware. So here I have this device on the table. I can say let's make automatic recognition of this connected device. I say here continue. This is a connection list, and in the connection list I choose here the connection via USB. I say continuous. I say I finish this here. So and here I see this is the JUMO meroTRON 108. So and here we see we have this meroTRON 108 only with this standard hardware, let's say. Here we have the option boards, and in this option boards we can give in total 4 of all these cards here. So what option boards do we supply? Now let's look to them. At first here it's possible to give more analog inputs. So we offer analog input cards, which you can give to all of these four slots. Then you have here a card with 3 digital inputs. Then there is a card which can count a very fast signal. So you can make a counter. Then we have here a card which we offer with an analog output. Then we have cards or a card with relay output with normally open contact. Then we have here a card with a changeover contact. Here the special thing is that we can switch 8 amps. Then the card with 2 relays, normally open contact. Then we have here a solid state relay. With this we can switch 230 volt AC. So and here we have a logic output with 14 volt, a logic output with 24 volt. And then here we have an open collector output with which you can switch a DC voltage. So from the interfaces we can fit the meroTRON with a serial interface with the RS485 interface like here. Now we can give it to the slot number 8. Then we can work with the Ethernet interface. This we can give to the slot number 7. Profinet is possible as well. If you want to fit this meroTRON with this Profinet interface, then you give it to slot number 7. Then I go here to continue. And here I see the options which are available here in this device. The math and logic. Now we can work in this device here with math and logic equations. Then we have here the possibility to make an enlargement with an PLC functionality. This is this option here, ST code, because we do the programming then in ST code. There's an option, hot channel, but I don't have it in this device. But here with this device, it's possible as well to work with a second control channel. Then we can control independent 2 different values. And here I go again to continue. And this is a summary of the hardware of my device. And I finish here. If I would give this configuration to the meroTRON, then the meroTRON has its default settings. What would make the meroTRON then? He expect on the first analog input a RTD temperature probe, a PD100, and 3-wire connection. Then, and this signal, this temperature is then automatically the process value. The controller works then as a two-state controller, and the controller gives the controlling output out with the output number 1. This is a relay output. I have in my application, almost the same situation, but one thing is different. I want to output the controller output not with the output number 1, with the relay output. I want to output it with this logic output. This is output number 3, because with this I want to drive a solid state relay. Only to give you an overview, I go here to the configuration, and there I go to the analog inputs. Now, and here we see a signal type. This is this RTD temperature probe in 3-wire. But here you see you have other possibilities. You can define here a thermocouple or a current signal, a voltage signal, and others. But in my application, I have this RTD and 3-wire connection. No, this is the same what I have in my application. PD100 is a standard. If I want to have a PD1000, I can choose here this other linearization. So and then I go to the controller menu, and here I see, okay, in standard it's a 2-point or 2-state controller. This is what we want to have here. And then controller inputs. Now you see here the actual controller value. This comes in standard from the analog input number 1. This is good. As all of our compact controllers, the meroTRON has a tuning method. You can make this auto tuning. In standard, this is the oscillation method. And this tuning method needs to know, is this a relay output which we use, or is this a logic output or analog output? But don't worry, because of the assignment to the hardware which we make later, the meroTRON has the information of the output type, and so I remain this here, or I leave this here as automatic. Then I go here to the outputs, to the digital outputs. And here you see the controller gives the controller output with this digital output number 1. We see it here. The source for this digital output is from controller channel number 1. The switching output number 1. This is, for instance, for heating. If we would have a 3-state controller which can cool as well, then we can use as well the switching output number 2. But switching output number 1, this is the one for heating. But here I say, okay, I don't want to have this on this output. I want to operate my thyristor power switch via this digital output number 3. And now I give the same signal to this digital output number 3. This is here a controller, and then we have here a controller number 1, switching output number 1. This is the right signal. The controller has 2 basic displays, and he can switch between the displays and can show different values, but here I only want to have at first this one display. Then let's look what values do we see in one display. So in this first display, here we see on top, we see the signal of analog input number 1. In general, this is absolutely okay. But I like here to give here the actual value of the controller. The reason is maybe later somebody changed the source of this actual value. And so if I make this setting here, then I can be sure that I see always the actual value. Then in standard, the controller does not display his output. But for this, I can say, okay, let's give here the controller output of this controller number 1. And then we want to have the output number 1. This is this output for heating. This goes from 0 to 100%. And finally, I make the data transfer to the device. Now I want to show you how to operate the meroTRON. Here in the display number 1 you see there's a process value with 21.7 degree. Then you see in green the set point, and the moment is 0 centigrades. You see here that we are on the basic display number 1, but the basic display number 2 is blocked, so we are not able to go there. And then you see the output of the controller. This is in the moment 0%. At next I increase the set point to 200 centigrades. The controller starts heating immediately. I see it here by the output number 3 because this output is active now. And in this heating up process I start auto-tuning. So now the controller changes its output between 0% and 100%, and he produces oscillation of the process value, but normally the process value is all the time below the set point. The controller analyzes this oscillation, and in the normal case the controller calculates reasonable parameters for the P, I and T action. So in the moment we heat and the temperature is increasing, then before we reach the 200 centigrades, the controller switched the output to 0. This is now the case. Now we have a delay in heating. Then we reach here a maximum value. The temperature goes finally down. The controller heats again. This is here the case. And after a little while, the temperature is increasing again. We have this here now. Then the meroTRON deactivate again the output. This is here the case. We reach the second time the maximum, and then the controller has calculated in the normal case reasonable parameters, and with these parameters we control now to the set point. From our other controllers you know that we have, for instance, a parameter level where you find all the control parameters, and you find a static configuration level where you can do the configuration of your device. With the meroTRON we go other way. Here you can prepare your configuration level, your parameter level like you want, and all the parameters you want to prepare or you want to change later on the device, you need to give to such menu levels. In a few minutes I go with you here on the meroTRON in the parameter level. So parameter level is in standard there where you can change all your control parameters. But at first I want to show to you how to prepare these levels in the configuration program. So in here in the configuration program I go to user interface, and here we have 4 menu levels, and later on the device we can reach in general these levels, and here we have something like an editor, I want to say. And at first I go with you to the menu level 3. Menu level 3 from our default settings we say here this is a parameter level. So we have a device with English language. This is why I work here always in the second line. So this is a parameter level, and the most levels they can work with different sub levels. So if I go here, then you see we have in general we have 4 sub levels, but in the moment I use here only one sub level. This sub level is called first parameter Z first controller. So and now we look what parameters do we find in this sub level, and I can do this here parameter, and so we gave all the parameters for changing the control behavior we give to this parameter level. So, and let's look. Okay, here I have the German words, here I have the English description. No? You see here, for instance, the controller structure. So later on the device, we have in this parameter level, this parameter controller structure. And here we can define later if this should be a PID controller, a P controller, whatever. Or here we have the proportional band. No? And you see you can give different parameters or all of these parameters to this level. Yeah, but in standard we have here the proportional band. Then we have here the derivative time, we have a reset time, and all these parameters are for the first controller. And here, okay, as well, switching period. And all these parameters you can see in this menu level 3, so in this parameter level. And now I want to show you this on the device. So the controller hasn't reached 200 centigrades so far, and now I want to go with you to this parameter level. This is this first menu level. Later I give you information about this. And here this is the parameter level, and like we said, for this parameter level there's only one sub level. This is this first parameter set first controller. And when we go there, then we see these parameters. Now here we can define the structure, like we have seen the configuration program. We can define a proportional band and the derivative time, the reset time, and the switching period. To show you the control behavior, I define here a set point of 190 degrees. And then we want to go to manual mode. In manual mode you can define an output of the controller. Now I go here to manual mode and I define an output, in my example, of 0%. Then the power goes down. And finally you will see that the temperature in general follows, so the temperature goes down as well. So finally I leave the manual mode. So then we say we go to automatic mode and the controller controls again to the defined set point, in this case 190 degrees. So now I want to show you how you can extend the hardware of the meroTRON. Then we want to extend our configuration. We want to implement a 2-channel controlling. Then I want to show you that you have the possibility in the configuration program that you can see your connection diagram depending on the hardware, what you have and the configuration which you have done. And then I want to make a little bit more clear how to create this menu levels. So how to manage this user interface. So now we want to use in the meroTRON this second controller channel. So we want to implement the pressure controller. This means there is a pressure transmitter, and this pressure transmitter outputs 4 to 20 milliamp, which represents the pressure. Then we want to have a continuous controller, and this continuous controller should output its output via a 4 to 20 milliamp signal. So for this example we need to extend our hardware with 2 option boards. We need one option board with an analog input and one more option board for an analog output. Exemplarily, I show you here how to extend the hardware on this example of this analog output card. Yeah, here you see the card in front of the controller with which we want to extend the controller hardware now. On the back side of the controller there's a cover. I remove this, and now I can give the analog output card to one of the 4 option slots, and here I use the option slot number 1. And finally I close the housing of the meroTRON. So and now I need to adapt my file in the setup program here to the extended hardware. Therefore I go to identification and then here to device version, and then I make again automatic recognition. So I need to connect again via USB. And here in the summary I see this extension. You see here option card 1 is the analog output, option card 2 is the analog input. Now I finish this, and then here my file is adapted. So now I do the extension of my configuration here for the second control channel. We said the second channel is for controlling a pressure. There's a pressure transmitter which supplies a signal 4 to 20 milliamp, which represents 0 to 6 bar. So this means I go to the analog input to number 2, and here I say this is a signal 4 to 20 milliamp. It's a pressure signal. I define here bar, and here I make my scaling. 4 milliamp represents 0 bar, 20 milliamp represents 6 bar. Then I go to the configuration menu of the controller, and I go here to the second controller, and here I say this is a continuous controller. Then in the controller input I clarify that the analog input number 2 is the source for the actual controller value. And here again, for auto tuning, it's not necessary to define here the output type, because the recognizing goes automatically. Now we need to give this controller output to a continuous output. There I go to analog outputs. There is one analog output, the output number 2, and here I give the source for this output. I go here to the controller menu, and I choose here from the controller number 2 the output number 1. For this continuous output I have only this output number 1. If I would have a 3-state controller, then I would have this second output as well, but here this is the right setting. So we want to have output signal of 4 to 20 milliamp. So and then we say there's an output from 0 to 100%. In proportional to this we want to output a signal from 4 to 20 milliamp. This controller channel is later visualized in a second display. So we were there before. Here in display and operation, here we see a number of basic displays. Later in the basic display number 2 there will be shown the controller channel number 2, and there we have the possibility to operate this controller channel. Now we define what we want to see in this basic display 2 later. So if we go there, then we say on top we want to see the actual value of this controller number 2. So where is this? It's here, actual value or actual controller value 2. And then we configure it that we see in this display number 3 this first controller output of this controller number 2. So and now I want to modify my parameter level. Before you have seen there were a lot of parameters in the parameter level which we don't need for this 2-state controller in channel number 1. So I only want to delete a few parameters there at first. So then I move here to user interface, and we set parameter level is in menu level 3. So we see here, okay, we use the English text here, parameter level. Sublevels, there's only one sublevel, and here we see all the parameters, and here, yeah, we have the English description. And here I want to see on the device later only the controller structure, the proportional band, the derivative time, the reset time, the switching period. That's it. The other parameters I want to delete now. And with this activity, the parameters will not be in the parameter level on the device. So now I want to create one more sub-level for the second controller. So let's go there. By copy and paste, I want to use this text here, and I say, oh, there's a new sub-level, and here I give a name. This is now the first parameter set of the second controller. And this is now a new sub-level which I can see then later on the device. So, and in this sub-level I only want to give for this controller channel number 2 the structure, the proportional band, derivative time, reset time. That's it. So I go now to the parameters, and now I say here I have a new parameter. New parameter. I have a new parameter for this other sub menu here. I give there, and there I say I want to have from the second controller the structure. Okay, first controller structure will be later the description. This is okay. Then the second parameter. Second parameter is for the second menu as well, or for the second submenu. And here I say from this controller number 2, I want to have here the proportional band. And like we said, we want to have here the derivative time. And we want to have the reset time. Yeah, and that's it. So and now I want to look with you to the other levels. For instance, here is menu level number 2. So you see this level number 2, there are no parameters. This means this level will not be shown on the device. Then we have the menu level number 1, and this level we called startup, and here you have parameters for startup. So maybe you want to make settings for the analog input number 1, for instance, for the controller, and for the digital output, so the source, for instance. No? So all the parameters which you want to configure later via the device, you need to give to such a level. So maybe here we say, normally we do the startup of such a meroTRON always with a configuration program. We don't need these parameters on the device. Then we can delete all of them. And I do this here. And when I delete all the parameters, then I will not see this menu level anymore. So and this is in general here my configuration. And now I want to show you a functionality which is very comfortable, especially when you work with these option cards. So in the configuration program, depending of your hardware, depending of your configuration, there's a connection diagram. So you can see how to connect the device. So let's look where we can find this. Here in identification. Here you have the point connection diagram. And in this point, or in this submenu, you can see how to make the connection of your device. Now you see here, for instance, this is analog output. You see how to connect the actuator via the 4 to 20 milliamp. This is this option board with the analog input. You see how to give the signal from the transmitter there. Or here, for instance, there's the wiring of this RTD temperature probe and 3-wire connection. So in the configuration program, the work is done. And now we can give in general this configuration to the device. So and now I want to show you the operation of this second controller channel. Here in the first basic display we see again the temperature controller. And now I move to this basic display number 2. Here the pressure controller, the second controller, is displayed. So and here in this basic display number 2 we see the actual value of the controller, the set point and the output. And now I define for the second controller a set point of 5 bars. And immediately I start here auto tuning. And then the controller makes this auto tuning and find reasonable parameters. Now auto tuning has finished and the controller controls to the set point of 5 bars. And now I want to go to the parameter level. And maybe you remember before there was here a startup level, but we deleted all the parameters in the configuration program. And this is why we skip here this startup level and we reach directly the parameter level. In the parameter level I reach at first this first submenu. This was here parameter level, and the submenu is here first parameter Z, first controller. So here we can reach the parameters of this first controller. But now we go here to the second submenu. This is this first parameter Z of the second controller. And now we can look here for the these parameters. We see again the structure here. PID structure. Here we see the proportional band, which was defined by the auto tuning. We see the derivative time. We see the reset time, but from this channel number 2. And more parameters I don't have in this loop. So and we see here the channel number 1, the temperature controller. And let's go again to this pressure controller, to this channel number 2. And okay, you can imagine then that I can switch this controller as well to manual mode, and I can specify other output. So here for instance 0%. Now I only want to show you that you have here this possibility for this controller number 2 as well. The meroTRON includes a data logger, and with this data logger you can record for analog signals and for digital signals. And after your logging you can give all these data to a USB flash drive. Then you will find on this USB flash drive a CSV file. So let's make an example. We want to log the 2 actual values of the both controller channels. Therefore we activate here this data logger function, and in standard we save each 10 minutes our values. So then I go here to analog signal, and here I look to my controller 1, and for the controller number 1 I want to record here this actual controller value. So here, okay, here we work in standard with a German text. Let's change this. Here we say actual value controller number 1. Then we look for the actual value of this controller number 2. And again we change here the text. And this is in general our configuration. Digital signals you have seen, this is possible as well, but we say we don't have something in our application. Then I can go to data logger. Okay, with 10 minutes the data logger is sufficient for 2 years. And when we come later with this with this USB flash drive to the controller, and we give the values to this flash drive, then the whole content of the data logger will go to this USB flash drive. Maybe we say, oh, we need to have the values each 2 minutes, and then you see here how the maximum recording time goes down. Now with this interval, it's approximately 5 months. And here I want to show you how you can get the values from this meroTRON. Here we put the USB flash drive to the meroTRON. I can use a USB flash drive for transferring a configuration as well, but this is not what we want to do. We want to give the data of the data logger to the USB flash drive. And this we do now. And now we take the USB flash drive, and on the USB flash drive we find this CSV file. And here you see the content of the CSV file. So you see line by line with each memory cycle, you see that you have here the values of these chosen variables. So with this we reached the end of our webinar. I hope you know now the meroTRON a little bit better. In my opinion, you need to make the startup of the meroTRON always with the configuration program. If you say later it's necessary to make on the device changes in the configuration, then you need to give all these parameters in this user interface in these different levels. So I hope you enjoyed this webinar. Thank you for your attention, and I hope to see you and hear you again. Bye.